Today, I will be sharing our recent findings named One Body but Four Hands, exploring the role of virtual hands in virtual co-embodiment. My name is Jingjing Zhang, and I'm from the Hong Kong University of Science and Technology in Guangzhou. Here's the content for our presentation. Our research builds on traditional motor skill learning, highlighting how virtual reality enhances these processing from the third person to the first person perspectives. In VR, co-embodiment allows the participants to share the same virtual avatar, which can significantly enhance the learning and retention through an updated body schema. However, there is a mismatch location between the user's own hand and the co-embodiment hand. We can see the red picture. The hand position of learners and the teachers are different. We investigate the impact of using the virtual self-hands and the co-embodied hand for the learners in the virtual co-embodied task. Our studies focus on virtual hand appearance of self-hand and the co-embodied hands, affect the user's sense of ownership, sense of agency, and the social presence in this virtual cooperated environments. In this work, there are two research questions. Firstly, how do virtual self-hands beyond the co-embodied hands influences the SOO, SOA, and social presence? And then how do the hand transparency and the congruency influences these perceptions in VR co-embodiment scenarios? We divided into two user studies to further understanding in this research. The study one examines the extent of virtual self-hands in co-embodiment scenarios. Firstly, we tested the two conditions, and then the study two focus on the concepts of transparency and congruency, including the four different conditions affect the user perceptions. The contributions of our studies, including that the extent of virtual self-hand significantly enhanced the SOO and SOA, and it also showed that the self-hand with the co-embodied hand strengthens SOO, highlighting the cultural role of the congruent virtual hand design. So we suggested the importance of enhancing the virtual references through the self-hands to improve the user interactions in VR. Then the first of variety works about our research. Co-embodiment involves two users sharing and controlling the one single virtual avatar in virtual environments. This approach is particular benefit for the scale learning and collaborative task as it can be enhance the SOO and SOA of the virtual avatar. There are two methods about the co-embodied avatars in VR. You can see these two pictures. In our studies, we only focus on the weighted basis method. It can assign the movement from the two users influences based on the specific weight ratios. And as the SOA and as SOO could increase it with the higher weight ratios assigned to the user's inputs. Co-embodiment avatars in VR enhance the physical and motor skill training by enable the learners to observe and following the teacher's movement from the first-person perspective, which significant for the SOA and SOO. As it has been shown that the co-embodied leads to higher learning efficiency and better long-term retentions of motor skills compared to the traditional observed methods. It also allows for the accurate replications of teachers' movements, integrating these movements into the learner's body schema, thereby strengthening the SOA. Current VR co-embodiment has a wide range of applications, including the training and rehabilitations. SOO and SOA are two subcomponents of the sense of embodiment. SOO refers to the perceptual illusions where a person feels that a virtual body or a part of it. This sense of ownership is important for the immersive experience, and the higher SOO with the realistic or personalized the hand. The SOA is the experience of having control of movements within the virtual environments and making the users feel control these actions of this avatar. The social presence is about the feeling the company of another users being with the same virtual space. Advanced movement capture technology not only enhances sense of presence, but also fosters a feeling of co-presence, which is vital for collaborative and social interaction in VR. These three user perceptions are important for creating the engaging visual environments where users can interact naturally and effectively using the VR co-embodiment avatar. Visual aspects of avatars are influences the SO and SOA. The design, the realism of this avatar can enhance the whole user feel connect to and in control this visual selves. Several studies have shown the different levels of realism in avatar designs can significantly impact the user reactions. Transparent avatars help in the task performance by inducing the visual occurrence and providing the essential body cues. And the congruency between a user's avatar and others can enhance the SOO and self-identifications. Despite the exciting the studies, the impact of visual factors involve self-hands and co-embodied hands remains underexplored. Potential research areas include understanding the how different visual design influences co-embodiment experience and evaluate the effectiveness of various avatar designs on learning and interactions in VR. Research involves a bilateral coordination task based on the dual task paradigm where participants using their hands to draw different lines at the same time in their collaborations with a virtual agent. You can see the left pictures. The human and agent control the same avatars in our studies, and the detailed experiment task about how to collaborations is shown in the right picture. Participants interacted with the avatars that are either realistic or having a ghost appearance. We use a metal crystal tool with two controllers within the simple virtual room, and the weight adjustment method implemented gives each participant and the virtual agent 15% control over the movement. When we explored the effect of virtual self-hand existence on participants' SOO, SOA, and social presence, there were two experiment conditions, one only with the co-embodied hands, and another includes the self-hand and the co-embodiment hands. The studies involved 15 participants and used a subjective questionnaire to gather participants' experience. Three experiment procedures include the preparation, tutoring, and the main task. All the studies were approved by the university. We use the software to the data analysis and ensure the normal distribution with the test. This finding suggesting that the visual representations of one's own hands in VR significant enhance both SOO and SOA. In study two, we investigate the effects of visual sightings of visual hands, focus on their transpirations and congruency. On user experience in the co-embodiment task, so it assessed the two main factors, transpirations, whether the hands were the ghost or the realistic appearance, and congruencies, whether the hands appeared identical or had different appearance between the self-hand and the co-embodiment hands. This study includes 21 participants and the methods mirrored the study one, involving the similar experiment setups and data creation technologies. Participants will involved in the task under 4 different conditions. Condition 1 and 2 with the realistic and congruent hand between the two hands with the realistic or the ghost hand. Condition 3 and 4 had the incongruent hand between them with the realistic or the ghost appearances. We use SPSS for the primary analysis and R software for the handling the normal data. We observed a significant interaction between the hand transpiration and the congruency, suggesting that the whole user perceives their visual self-hands and co-embodiment hands can affect their SOO. There were no significant effects or the interaction indicates a minimal impact of the hand settings on SOO and the social presence. In this discussion, in conclusion of visual self-hand significantly enhanced the user SOO and SOA participants report a connection with the visual environments, perceiving the self-hands are directly extensions of their own body. Full control over the self-hands correlated with the increases SOA. Participants show a preference for the door or visual representations, which help them more accurately perceive and control their real and virtual positions, thereby enhance their interaction effectiveness. The interaction between the different levels of the hand transpiration and rhythm introduce the complex dynamics in user experience. More transpiration hands can affect the degree of SOO with varying impacts based on the task aims on the environment's rhythm. Identical hand appearances as explored in condition 1 and 2 lead to a higher SOO. The overall consistency could reduce users' confusions. There are several design inspiration for VR co-embodiment. The first, the introduction, introducing additional overall hands that mirror real hand movements can help users better own their movement with the overall environment. Design the minimal. Designers should consider the characteristic of the task and the potential impact of social presence in the multiple person collaborations ensure the system is responsive across the different user actions. In these sections, we addressing the limitations of our studies and propose a future research to enhance the findings and apply them more broadly in the field of VR co-embodiment. Firstly, about the sample size, a large and more diverse group of participants is needed to extend these results. Then control rates, we only test with a 15% control rate for the visual representations. It would be beneficial to explore how different control rates of visual hands in future work. Thirdly, participants experience cognitive confusion when user self-hand and co-embodiment hand will choose close. The future work could reduce the cognitive load and improve task performance. Our study relies on subjective measurements, and future studies should include objective measurements such as the task completion time and the design task with the various levels to better assess the effectiveness of virtual interventions. In the conclusion, our primary objective was to explore the impact of extent of oral self-hand and the effects of hand transpiration and congruencies on SOO, SOA, and social presence in VR co-embodiment tasks. Our studies contribute to understand how visual factors of virtual co-embodiment hand and self-hand can affect the participant's subjective experience in VR environments. We highlight the importance of visual design choices in visual hand representations, which can significantly affect users as a whole in collaborative VR settings.